Cool. So I guess we should start by explaining what it is that we're doing here. And what I'm going to do is I'm going to take you through what our service level indicators are and how we're using those to figure out the reliability of all of the services in GitLab and how we're extending that out across all the services.
Sounds good.
So I guess what I can do is I'll start with a little demo and I'll just kind of walk through all the different pieces. And then from that, we can go and you can ask some questions and I'll dig into it a little bit further. So I've kind of started off on this page, which is the SLA page. And so this is kind of telling us, according to all of these metrics that we've been recording, how much of the time we are within our accepted target or our targets for SLO. And so you can see over the last, this is 30 days, you know, it was just under 80%. And now it's up at 95, just somewhere above 95%. Now, the really important thing to kind of keep in mind with all of this is that some of the metrics that we are using are very low quality. And so the reason why we've seen this is because the quality of the metrics that we've been using was really bad because Sidekick wasn't emitting metrics properly and we were getting very bad numbers from Sidekick. And so, like with any SLA framework or any sort of KPI, you know, it's garbage in, garbage out. So one of the things we have to do is, I kind of feel that we have the framework in place, and the big challenge now is to kind of focus on the quality of the metrics and to make sure that, you know, if the Sidekick metrics break, we fix them, you know, that release, or we revert the change that did it, rather than, you know, that change was in for over a month before.
Right.
And incidentally, during that time, we had very little observability into Sidekick. And so kind of while I'm walking through all of this, you might kind of be looking at the numbers and going like, oh, like 85%, that's rubbish. Like this is a rubbish framework. But I feel that the framework is good. We just have to improve the quality of the data that comes into the framework in order for it to really start seeing the results. And, you know, as I said here, you can see Sidekick only achieved its SLA 61% of the time. And Git as well. I don't quite know why that is. Oh, it's related. It's the same problem, actually. It was a problem in the Prometheus Ruby library. And then sort of from there, we're starting to go into more reasonable figures. But I'll walk through that. And then this is kind of how each of those is trending, how each of the services is trending over time. One of the other things that we were just talking about before we started recording was the first time I opened this page, it only had 3 items on it. And it actually looks like we're still missing a lot of the items here. Oh no, sorry, I beg your pardon. This is because this is the primary services. So I exclude sort of services that aren't user-facing from this dashboard. But I guess the best thing to start with is how it started. So for each of our services, we have a set of key metrics, right? And so it's kind of a combination. There's a guy called Brendan Gregg, who's like a famous observability guy. And he came up with this approach called the use method, which is utilization, saturation, and errors. And then there's another guy called Tom Wilkie, who's the VP product at Grafana. And he came up with the red method, which is requests, errors, durations, right? And our key metrics are kind of a combination of those two for the metrics out of those that suits our workload and the way that we work as a company. So it's a little bit of both. But we have, for each service, we're trying to record latency, which we record as apdex. So is this service running within reasonable parameters for how fast it should run? We have like an error rate, and that's always a rate. It's not there were 50 errors in the last minute. It's always there was 1% errors in the last minute. So, you know, it's much better than fixing on 50, because we're a really fast growing company, and last month 50 might seem like a lot, and this month with growth 50 is small. And so it's much better to use those ratios. The third one we have is the request per second for every service. So if you are Redis, you might have, you know, 100,000 requests a second, not 100,000, but 1,000 requests a second. If it's the web, it might be 100 or whatever. You know, those are bad examples. And then we also have saturation. So I'll just, and what I've been trying to do is put these metrics in place for every one of our services. So on the new dashboards that we have been building, you'll see that each of them has got a link to the main services in the application. And those are in this like links bar up here. So we've got API, CI runners, front end. That's what we call HA proxy. Giddily, monitoring, which is Prometheus and Thanos, pages, obvious, Petroni, obvious, etc. So each of these dashboards kind of looks the same, and it's kind of like the standard dashboard for a service. And so the first thing you'll see on each one of these dashboards that you go to is this headline metrics, and that's your service metrics, right? Or your key service metrics. And what I was saying just before we started the recording was that either Thanos or Prometheus or something is feeling pretty slow this morning. So I've noticed that you know, all of these requests are taking quite a long time to come back, which is a bit of a pity. Maybe we can edit the video and chop out some of this.
No, I think it's important to also note that you mentioned that Thanos goes to multiple backends, so multiple Prometheus to gather all the data. And when it fails to get data from one, it will just hang. So basically, the data you're getting is incorrect. So
well, it's actually worse than that, because it'll time out and then it will silently time out. So it'll give you the data that it's got, but it won't give you the data that's missing. And obviously it could be critical data that's missing and you're not even aware that it's missing. Yeah. It's kind of like you don't know what you don't know.
Yeah, that needs to be handled prior to us depending even more on this. I mean, we are depending already on it. But
yeah, I mean, this is one of the reasons why this is quite a technical thing, but the place that we evaluate the rules. So for each service, we evaluate a bunch of rules to say, you know, is a service healthy or not? And we can either do that in Prometheus, or we roll all the Prometheus data up and we record it in Thanos as well. And so obviously in Thanos, we get this kind of global view, but what we continue to do for the moment is evaluate those rules at the Prometheus level, because I'm more comfortable with its reliability. So it was actually my fault, because I had that set to 30 days from our previous discussion. So live demos, eh? But here you go. So I've set this to 12 hours now. And so here, this is the API service. And these are our 4 key metrics, right? We have apdex, error ratios, request per second. And with the request per second, you can see we've got the normal boundary. And that's where we kind of expect the data to be at this time of day on this day of the week. And so if that yellow line spikes up above the green area, then there's probably something weird going on and it might be worth investigating. And then we've got the saturation metrics. And so these saturation metrics are not directly part of the SLO framework. But obviously, if your metric becomes saturated, it will have an impact on your errors and your apdex. And therefore, you know, we don't need to double record it. The fact that a user seeing an error is sufficient, right? So I'll just show you for like another service, like Giddily. It's quite a different service.
Maybe it would be nice to check out Registry.
Okay.
I'm curious about some numbers that I saw there, so I just want to like go through that with you.
Okay, great. So let's go here.
Mostly because it's a stateless service, so I'm like wondering why it's below 99.
Sure. So okay, so this is the registry. So the registry uses this general dashboard. So I haven't created the registry dashboard in Grafana yet, and so this is kind of a generic dashboard. You can choose registry from the top here, and it gives you the data. Sorry about that. Let's just wait. Cool. So, okay, so this is, you can see the registry over the last 24 hours. Sorry, this is 12 hours. So the rate at which we were getting requests is like, you know, somewhere between 300 and 400, and that's normal. Component availability, I've started moving away from. It's basically a ratio of how many of the servers that are supposed to be, or processes that are supposed to be serving the registry are running. And really what I found is that that on its own isn't a very useful metric, because, you know, 90% could be running and everything could be fine. And you don't need to wake them up in the middle of the night for that. It's only when it gets to the point that the latency starts rising or the error rates start rising that it's a problem. There's also another really important document that I should link in the notes for this, which is there's a Google Doc called My Philosophy to Alerting. And have you heard of it?
No.
It's an amazing doc, and it's kind of like the way that everyone's moving their alerting. And so what it is it makes a distinction between cause-based alerts and symptom-based alerts. So the metrics that I've been trying to focus on are symptom-based alerts, right? The user is experiencing errors. The user has a slow service. And the other type of alert is a symptom, is a cause-based alert. So the cause-based alert could be like, this metric in the application should be below 5, right? And if you go through our alerts, all of our Prometheus alerts, we have like 95% of them are cause. And the problem is every time you have an outage, you'll create a whole bunch of new alerts. And then nearly every time, what will actually happen is different, or it'll be slightly different and the alert won't fire, or the alert just fires all the time, which is actually even worse. And we see lots of that. And so there's kind of been this movement to symptom. Users experiencing like a bad thing. And you have way less alerts, and generally they're much easier to tune to get right, and they're also much more reliable. And so with these alerts, we're trying to go to, you know, 2 symptoms: speed and errors, and really that's it. So going here, there was something that you wanted to ask about these.
So if I take a look at the error rate ratios.
Yes.
It is quite clear that during 2 deploys that we had, I'm guessing Canary, we had a huge spike in errors.
That's Canary, and that is Canary as well.
Canary.
Yeah.
So we have something to look into there, because that should not be happening during deploy, because we are not rolling out new registry. So this means it is GitLab related. GitLab is unable to serve certain requests or authenticate or do whatever, and we need to figure out why. I'll take that as an action item for my team.
Yeah. So one of the things that can help here is that for these alerts, these are aggregated, right? Because what we call a service is not a single process. So we have a service called the web, and that is like a whole bunch of things that work in coordination. So the web is Nginx, Workhorse, Rails. Those are probably the 3 main ones in that example, and they work together, right? And so to come up with an error ratio, we actually sum all of those things together. And so one of the things that can be really useful is to go look at the components of, so we call the Nginx, the Workhorse, and the Rails components, and rolled together they are a service. And so if you go look down here, you can see what the components of the registry service are. And in fact, with the registry, there's only one. So it's just the process. So not very exciting, but sometimes if you open up this component metrics over here, you can get some interesting information about which component is erroring. But going back to here, so this is kind of a good example and a bad example, because what you'll see here, this is our metric, and then there's these 2 different dotted lines, right? The lower one is our what we consider a degradation, like the service is not great, it's degraded. And then the upper one, the sort of dottier one, the bolder one, is our outage, right? And so when we reach that level, we consider that this should be an outage. And each service has got a different SLO. And what you'll find is that this is always halfway between 0 and your outage. So we just calculate it as halfway. That's when you've hit degraded. So in fact, we only specify one number for each service. And some services like Gitly, I think it's 0.1% because we see very low error rates in Gitly. But then for some services like Sidekick, it's something like 5%. So there's a very big variation, right? The other thing, the reason why I said that the registry is a bad example is because here there is no line. And what that means is that we have not defined an objective, a service level objective, an SLO, for the latency of the registry. So this can kind of go up and down and nothing will happen.
Nothing will happen.
Right? And we need to probably just put one on here. The reason we don't have this is kind of historical. We didn't have latencies recorded when we did the SLOs, and since then we've got latencies, and so there's a bunch of reasons why. It's not just forgetfulness. Now, the other thing that's kind of interesting is that we've got a general symptom-based alert, which is to say that for any service, if the metric exceeds the degradation, we'll get a warning. And if the metric exceeds the outage line, we automatically get an alert. And the next stage of that is, if you go look in the SRE book, there's, it's funny because they call it error budgets, but we use error budgets for a totally different term. But they have a way of, like the speed at which the error rate rises and how high it goes, because you can have slow burn errors and you can have spiky errors. They have different thresholds. And I have a plan of how we're going to implement that quite straightforwardly. So that's going to be the next step. But at the moment, we've got the static line. If this goes above that, we get an alert.
Alert, yeah.
So let's go look at Gitly quickly. So again, here's our metrics, and you can actually see, like right now, Gitly is below its SLO, right? It's degradation SLO. And the errors is below, so that's good. But the updex, that is to say the number of requests that complete within an acceptable time period, where acceptable depends on the request, is below, below 99%. I think that, yeah, the SLO is 99%. So we expect that 1% of requests take longer than we expect them to. And at the moment, it's more like 2% of requests are taking longer than we expect them to. So this will have actually generated an alert that would go to the alerts general channel and would have also raised a PagerDuty. Well, actually, if you look at it, it's very spiky, and it has to exceed for 5 minutes in order for us to get that alert. And I suspect, yeah, you can see what's happening here. It's kind of going up and going down, and because of the way Prometheus does alerts, it has to be below the threshold for 5 minutes in order to alert. So we may not have got an alert for that yet. Anywho, so we've tried to extend this across each component in the application, and we've got the service catalog, and that's where we define where services are, and then each one of them has each one of these is intended to have an SLO for latency and an SLO for error rates. The next thing that we do is that we can say for each service, we can say how much time does this service spend within its service level objective, right? And so we could say that for the amount of time. So here, this is kind of interesting because over the last 7 days, so pretty much most of the new dashboards have the service health row, which I don't open by default because you don't need it all the time. But when you open it, you can see that this latency metric is meeting its objectives about 72% of the time, right? And on Giddily, the error rate is actually been much better. It's meeting its objectives 98% of the time. So that's not too bad. There has been some issues over the last week. So that's probably where that's coming from.
So can you tell me what those two combined actually tell me about the health of the service?
So really, when you combine them, what you get is kind of an overall view of a ranking of all the services in the system, right? So I think that's the best way to look at it. Like, this service is meeting its objectives like 100% of the time. This service is meeting its objectives 70% of the time. This is a service where we need to put some effort in. Obviously, that effort could be, let's review our objectives. Are they valid? The second thing is, are our metrics valid? So there's it's not all. Or the third thing is does the service have some sort of problems that we actually really need to investigate and fix? And so it could be any of those three things. I would expect over time that, as we iterate on this, the metrics will get better and our objectives will get better. And what will be left is like application problems. And obviously the other thing is that this gives you like a long-term trend, right? So, if Giddily's been working really well and it just starts decreasing, we will see that in this graph. So going back to the SLO dashboard.
Can you just leave it for a sec? Yeah. One thing that is, and FYI, I have a motive for asking this question, but I see in the saturation that a certain server keeps, or certain metric actually keeps going above a certain threshold. Can you tell me more about that?
Yeah, okay, so this one over here, if we look over there, this is just intended to be like a small quick view. So when you open up the dashboard, you get this. So we'll go down, we'll scroll down to key service metrics, the first prize middle icon. And you can see here on the saturation that the metric that is alerting on here is called single node CPU component. One of the things that I'd really like to do is include documentation in Grafana, like right here in here, what that means, because I know what that means, and like a handful of other people maybe know what it means, but not everyone. But I'll explain to you what it means. It means that we have 40 Giddily servers, 41, 42, I don't know, somewhere around there. And most of those Giddily servers are sitting at like 40% or 30% CPU, right? But one of them is sitting at 93% CPU. And all the requests that are going to that Giddily server are getting slowed down, right? So it is saturated. And so it is the bottleneck on CPU. So what we do is we look at the average CPU for each computer in a fleet, like in the Giddily fleet in this case, and we say, what is, out of all the averages, what is the worst case? And here you can see it's that. So recently what I did was, because you always need to drill further, this is just like a headline, like health check. I've added this thing called saturation details. And so we know that the problem here is single node CPU. And then if we go down here, you can see that the server, so this is effectively that same metric without any aggregation on it, right?
Yep.
It's expanded out. So you can see here that the server that is, and this is always ordered by top to bottom. You can see that the server that's in problem is Philo 2. We know what that is. Yeah. That's where GitLab or Git is. GitLab is kept, and there's something very strange going on that server at the moment.
Yeah. So basically,
by OID.
I'll try to translate this in other words. If I get it wrong, correct me. basically the fact that this one server is spiking so much and causing so many issues for projects that are on that shard means that our whole Gitly service on all nodes, so all 40 something, is being I don't know, degraded as the overall service. So
that's right.
Okay, so basically, if we have a healthy service, any small part of that service, any component of that service can actually affect it, and that can give you a clear overview that something wrong is happening. You need to dig deeper, rather than,
that's right.
Oh, I'm just seeing a metric, something is wrong. No, like you need to dig deeper for sure.
So, okay. I mean, the other thing that's worth stating, right, is like, people could say, well, it's only requests on that server, and we could just take GitLab Git and move it to GitLab or GitLab and move it to its own server. But if this carries on, the problem is that, like, saturation, like, obviously often leads to downstream saturation. So if you have a lot of requests that are all hung up on a Git server or a Gitly server because that Gitly server is really struggling, then you start holding on to like a whole bunch of unicorn workers upstream. And so it's like a bit of an infection, it spreads. And so it will affect other people on other servers because the bottleneck will kind of back up backwards. And the analogy that I always like to use is like, sometimes you're driving along a motorway and there's like a little road on the side that's congested, right? And like, it doesn't really matter very much, but all the cars that are trying to get off on that off-ramp are kind of backing up, and therefore they back up like a huge motorway because of one downstream resource, right? That's saturated, the road. And so it kind of spreads backwards, and the same thing happens with computer traffic. It's a bit of a weird analogy, but it works for me. But so yeah, I'm actually really happy with these graphs, because you can see before, we would see things like, we'd see these spikes in write throughputs on the Gitly fleet. And the problem with this is that it's very useful from a reporting point of view, but it's a little bit abstract. Like, people are like, what does that mean? And now that I've got these detail charts down here, you can sort of look for write throughput saturation. And you can see that this is happening on file 38 and file 37 and file 38. So it gives you like a very good idea of where the problem is. And I'm pretty happy with it for that. And these charts are actually reused through different services. So depending on what saturation metrics a service is constrained by, it'll have those charts. Cool. Should we move on?
Yes, please.
So that's most of it. Just to kind of tie that all back in here, like what we've been trying to do is we saw that for the Gitly service we were 75 and 98%. Where's Gitly here? Oh, we don't actually include Gitly on this, and I'll explain why in a second. But for each of those services, this number is now the combined amount of time that the error rate is above its SLO and the latency is above its SLO, right? And so Sidekick's terrible, but we know that that's a data problem. Git is also not bad, same data problem. And then these ones, this is a really interesting one because we've got a key metric for the company, which is to say that 95% of CI jobs should start within 1 minute. So this over here is actually based on CI jobs starting in a minute. That's our latency threshold. So for Gitly, we're talking about milliseconds. And for CI runners, we're talking about 1 minute. And that's what I really like about Apdex is you can scale it between these different things and just talk about a percentage, like what percentage is meeting its threshold. And so you don't have to worry about these huge different scale differences. So the reason why this has only got Sidekick, Git, CI runners, registry, API, and web is that this is the services that users interact with, right? And so if we did a really good job at architecting our system, which is obviously the direction we're going, you could have like a Giddily service that fails and has all sorts of problems. But if it doesn't impact the user, then you don't hold it against it. It's not a problem. And so these are the services that impact users. And so those are the ones that we have the headline figures for. And because we expect things to fail, but it's just that failure should not escalate up to impact users. And so that's why we've only got these services here. But if you go to any one of these services individually, you can see the numbers for that service. I'll just go to CI runners quickly. Oh, I just did this thing again. This is a slight problem because it keeps the dates as 30 days when you switch from that other dashboard, which has got a very long SLO. So. And what I'll probably do, which I haven't got at the moment, is on the service health row, I'll probably include like a nice long-term metric, like over the last 3 weeks, for the error rates and the Apdex individually, and you can see if they're going up or down, because we are sort of missing that at the moment. So here, this is our 1 minute, like how many CI jobs start in a minute. So Sid pretty much said, I want us to have a thing that all CI jobs start in a minute. And what's been great is that since we put this metric in here and we started focusing on it, this has improved drastically. So before this was like really bad, and Tomasz has been doing a bunch of work, and like the Verify teams have been doing a bunch of really good work, and this is improving. And the only time it's really bad is when we have a GCP outage or on the weekends, and Cameron is working on fixing the weekend problem. So we're going to continue to iterate on that. But, this translates, it's funny because this translates exactly to what the mission statement was, which is that 95% of jobs start in a minute. And so your Apdex score needs to be 95% or above. And when we started this, it was actually so bad that we set the SLO to 0, so that the degradation score was half of that, 50%, because we're getting so many warnings. And hopefully after this weekend, after Cameron's increased the number of runners, the off-peak runners to 70, I think we'll be able to bring this up a lot. So, and we can start doing that and
tightening that,
tightening it up. And that's kind of like the ultimate like goal of all of these, is like every so often just ratchet these numbers up a little bit, and then ratchet them a little bit more, and over time the service hopefully improves. So I think that's all the things that I've got to talk through. I don't know if there's anything extra that you want me to show, or if you have any questions.
No, nothing that needs to be in the recording. So
Okay.
Maybe stop the recording now.
Cool.